Okay, let's begin Unit 1 of Weather School. This will be a look at an introduction to meteorology. So this will be kind of the starting point for you to know what a meteorologist is, what they do, the lines of work they may be involved in, and we'll also get into a little bit about weather instruments, some of the basics about weather instruments and what are used to predict weather. So I think you'll enjoy this first unit. This is kind of an introduction to everything. And first off, I am a weather forecaster for Foothills Action Network. And what we do is we cover 8 counties in western North Carolina. We do weather strictly on social media. We're not involved with television or radio or anything like that. We are strictly social media. We have a website, foothillsweathernetwork.com. We have various Facebook accounts. We have Twitter. We have Instagram. So we do all of our information, on social media. So we do that. Also, we do weather support for local emergency management. One example is in McDowell County. We help do weather support for high impact weather events, whether it be a major winter storm, whether it be severe weather, uh, if we have a drought, wildfires, which in West North Carolina, having fires in the mountains can be very dangerous. We can provide weather support for emergency management to help protect the public. So we dabble with different fields, just public forecasting, emergency management forecasting. We even do weather support for organizations like the Hickory Crawdads Baseball Club, who, during the summer they have baseball games in Hickory and they want to know, is there a chance of thunderstorms on a specific day? Well, we can give you that or give them that information to help them plan for their events on a daily basis. So that is what we do at Foothills Action Network. We do a lot of things. We're not involved with TV or radio, but we do a lot of social media and we do a lot of work with local emergency management and organizations. So that's kind of a recap of what we are. Now, what is a meteorologist? I'm going to give you a minute to think about that as I ask this question. One of the first things that I have students ask me is, do you guys predict or forecast meteors or what's happening in the sky? No, we don't do that. That is not our profession. What is a meteorologist? A meteorologist is a person with specified education who uses scientific principles to explain, understand, observe, or forecast the Earth's atmospheric phenomena and or how the atmosphere affects the Earth and life on the planet Earth. Now, I know that's a very complex definition, but basically, we're going to explain what's happening, not only to people who like our forecasts on a daily basis, but like I'm doing today, talking to you and going over this program. We explain, we try to understand what's going on in the atmosphere, and we try to forecast what's going to happen. So there's a lot of things that meteorologists do. And as I said, what do a meteorologist do? Plenty of things. We study the atmosphere to help determine what the weather will be like. That is very important in trying to make a forecast on a daily basis. We want to know what's happening not only at the surface, but thousands of feet in the air, because it all plays a big role in the weather. We use computer models, we use radars, we use weather balloons, and we use weather stations to help come up with a forecast. We work for different companies. We work with TV, radio, or in our example, a private company to help alert people. The other cool thing, and this is something that really has become popular, meteorologists are also scientists in the field to study violent storms. And that is used for research purposes. Now, show you some examples of meteorologists and kind of going into the research aspect. As you can see here on the top left, the picture of the gentleman on the dirt road looking at the tornado. He is observing the weather. He's a storm spotter. He's a storm chaser. Shows all kinds of stuff that's going on. They're using that for research, probably taking some pictures, just looking at what's going on, observing the weather. On the bottom right is another example of using weather in the research field. That is the Doppler on wheels that is used during tornado chases to gather data, what's happening in that tornado, to help produce better predictions in the future. So weather for research is really key. And that's something that if you're not the type that wants to get on TV or whatever, just learning weather and using it for research is a great tool, and it helps everyone. On the bottom left-hand side, you've got the people in that office. That is a National Weather Service office. If you're not familiar, the National Weather Service puts out daily forecasts that are for the public. They're the ones that put out the watches and warnings during inclement weather. That is their job. And then on the upper right-hand side, the gentleman on the screen, he is a television meteorologist, and he's involved with media. So he's on TV daily giving you the forecast. So those are examples of the different jobs that a meteorologist can have. Now, one of the first things a meteorologist uses is weather equipment. Weather instruments are very important and can tell you a lot of different things about what's going on. First off is an anemometer. And here are two pictures. You got one here and one here. An anemometer is a common weather instrument that is used to measure the speed of the wind. Anemometer, wind speed. That's the thing to remember. Now, this is pretty simple how this works. You've got the two parts. You've got the revolving cups that you can see spinning around, and you've got the generator. Now, the revolving cups, essentially what's happening is if wind is blowing a certain direction, those cups catch that wind and it causes the whole thing to spin. So the faster that thing spins, the faster the wind speed is because it's catching that air. The generator is basically kind of the brains of the whole operation. It's the computerized part of the operation. It is taking that momentum that's making that spin, it goes into the generator, and then the generator essentially gives it a value. You know, is the wind blowing 5 miles per hour? Is it blowing 15 miles per hour? Is it blowing 50 miles per hour? That is what the generator is pretty much determining. Here's another example of that picture. You can kind of see the revolving cups and the generator in the middle, which is computing all of that wind energy. Now, the other part of wind, not only is it speed, but you probably want to know what direction is the wind blowing. Well, that is where a wind vane comes in handy. A wind vane is just a flat piece of metal or wood on a swivel that catches the wind and points it toward the wind. So think about if you live out in the country, if you live out and you see a barn or someone's old house, you may see a wind vane on the top of the roof. It's basically showing you the direction of the wind. If you notice, traditionally on a wind vane, you've got the four directions: north, south, east, and west. That is more or less just telling you what direction is what. And then the wind vane is pointing toward what direction it's going toward. So, an example, if the wind is coming out of the west, it means that the wind is blowing from west to east. If the wind is coming out of the south, it's coming from the south to the north. If it's coming out of the east, it's moving from the east to the west. And if it's coming out of the north, it's coming from the north and pointing to the south. So that arrow right there will spin based on the direction that it's coming from. So an anemometer measures wind speed. A wind vane measures the wind direction. Okay, the next piece of equipment we use is a barometer. A barometer is an instrument used to measure atmospheric pressure. It can measure the pressure exerted by three things: water, air, or mercury. Changes in pressure can help forecast changes in the weather. Now, the big key to know, and you'll see this down here at the bottom, high pressure, the higher the pressure is, generally the warmer, or not the warmer, but the more calm the weather is. The lower the pressure, the more active the weather is. So if you hear a meteorologist talk about low pressures coming toward your area, you're probably going to have active weather. If high pressure is overhead your area, it's clear, it's calm, there's not much going on. Okay, a hygrometer is another piece of equipment. A hygrometer is a device that is used to measure the relative humidity. The relative humidity is the amount of moisture present in the air. Now, can someone tell me what this is? I'll give you a second to think about it. Okay, this is a rain gauge, and this is one of the simplest things that you can have. If you're not wanting to do weather for a living, you can always do weather as a hobby. And one of the cool things to always have as a hobby is to have a rain gauge. So what does a rain gauge measure? Think about it. It seemed like it'd be pretty simple, which it is. Rain gauge measures how much precipitation has fallen, whether it be rain, snow, or whatever. Okay? Rain gauge measures how much rain has fallen. And then the last simple piece of equipment is a thermometer. A thermometer is a device that measures temperature or temperature changes using different methods. So what is it measuring? It's measuring the temperature. It's measuring how hot or how cold it is. So that's a talk about weather instruments, and I know showing this to you on slides, it's real interesting, but we're going to take just a second. I'm going to show you a couple more examples of weather instruments actually being used in real life.
Okay, we're talking about weather instruments and what you use to measure the weather. Here's an example of something that I use on a daily basis to measure the weather in my community. This is called a personal weather station, a PWS. You can buy these, and they range in prices from as little as $50 to as much as about $500 or $600. So depending on exactly how much money you have and how much interest you may have in recording weather data, you can buy personal weather stations. This one kind of shows you a little bit of everything that you can get. If you look at the top, you have the wind vane and the anemometer, which is measuring the wind speed and direction. If you look on the lower part of the base, that white shield is a radiation shield. That is used to help keep the thermometer and the barometer safe and keep it from getting worn out or for weather to potentially mess it up. Now, the white box on the front is a radiation and a solar panel. That is used to actually power the station and to gather the data. And the little antenna on the side of that box is what is used to transmit the data from that station to inside your house using a console. So you can always get this weather data live as it happens. And the last thing, the black part there, that is the rain gauge that is used to measure precipitation. It is a digital rain gauge. The accuracy on that rain gauge is about 85 to 90%. Okay, I was talking about rain gauges, and of course the one with my personal weather station has an accuracy of about 85-90%. But you can never go wrong using just an old school rain gauge. And this is what I have, and I'm going to show you how it works. Of course, rain gauges are something that you can buy at Walmart or any hardware store or online, and they're pretty cheap. You know, they range anywhere from $5 to maybe as much as $30. This is an example of a rain gauge I have. It's a really detailed rain gauge, and it has three parts. It has the cylinder or the funnel here that takes in the rainfall, and then it empties into the inner tube, and then when the inner tube is completely full, it empties into this outer tube. So here's how it works. The rain falls into the funnel and it goes into this inner tube, which is measured in 0.01 inches. So if this whole tube fills up, it's 1 inch of rain. But as you can see, there are holes right here on the upper part of this inner tube, and what happens is it spills into the outer cylinder. Now this outer cylinder, if it's completely full, can hold as much as 13 inches of rain. So if this thing fills up, that's a lot of rainfall. It can cause a lot of problems. These are easy to install. You just use a 4x4 post and you put this outer cylinder in here. Then you put the inner cylinder inside in the holding area, and then you take the funnel and place it on there, and then that rain falls into that and it collects. Always you want to have open areas. You don't want trees or your house blocking it. So this is always a reliable source. Anytime you can measure rainfall and measure temperature, even if you don't want to do weather as a profession, if you just want to do it as a hobby, that piece of equipment is good to have just to be a weather hobbyist.
And the last thing we want to talk about in Unit 1 is Doppler radar. Of course, Doppler radar, if you watch TV and watch the weather on a regular basis, is something that is used daily. Doppler radar detects precipitation intensity, wind, direction, and speed. It can also provide estimates for hail size and rainfall amounts. Doppler radar gives forecasters the capability of providing early detection of severe weather. Combined with satellites, radar can give forecasters the ultimate tools to provide accurate forecasts and advanced severe weather warnings. Now, how does a Doppler radar work? It is used using the Doppler effect. Now, let me give you an example and you may understand this better. Think of you being outside and let's say a railroad track is close to where you live. Well, if you hear a train in the distance, far off, it's a certain sound to you when you hear it, okay? Well, as that object or that train, for example, gets closer to you and the whistle keeps on blowing, it makes a different sound, okay? So the sound based on the distance to you changes. Then once it passes you and goes in the other direction, then you also hear a different kind of pitch, a different kind of sound. That is essentially the Doppler effect. It's the change of frequency of sound. So the Doppler radar is shooting out a beam, it's shooting out a pulse. And what happens is if it hits an object in the air, it bounces back to the radar. So that distance and the frequency is kind of how the Doppler radar works. So what happens is the Doppler measures the changes in frequency and then it assigns it and gives it a value. So when you look at Doppler radar and you look at the greens and the yellows and the reds, that is the differences in the frequency from when that beam was shot out from the radar, it hits the object and it comes back. So think about this. When that radar is shooting out in a beam, if it hits water, it's elevated in the air, it bounces back. So that's how it detects rainfall. Well, also, Doppler radar can do the same thing by detecting wind. So not only does a Doppler radar detect where it's raining or how heavy, but it can also detect wind, what direction, and how strong the wind is blowing. So that is the end of Unit 1 of Weather School. I hope you enjoyed this. Anytime, like I said, you have questions, feel free to email me at the address below. Coming up next will be Unit 2, where we'll talk about clouds and precipitation. As always, you can find our program, Weather School, at our YouTube channel, Foothills Action Network. Thank you. Have a good day.